C++ has a keyword in it called const, which you don't see in languages such as Java or Scala. And it has a slightly different meaning. In some ways, I want to talk about this in part because you need to know it for C++. It winds up being very important for how you do a lot of things in the language. On the other hand, it's also important to understand it just so that you can contrast it to other languages and how things are done in other languages, what things might be similar, and in some ways how some things can't be done at all. So to help illustrate this, I've started a little bit of code here. I have a main. I declared 3 variables, 2 integers and a pointer to an integer, which is initially set up to point to one of these other 2 integers. And then I set the value of one of them. And if I save that and compile this, it compiles just fine. And this doesn't do anything interesting. I'm not even printing stuff out, but everything's happy there. Now let's use the keyword const. So const can go on a type, and as the name kind of implies, it means that something is constant and you can't assign to it. So here we get an error message, line 8, error assignment to read only variable A. This is line 8 right here, and so it's saying A was a const, you can't change its value. This usage of const is very much like if you're in the Java programming language, the usage of final on a variable is similar, pretty much the same thing. Scala has no equivalent to this. You can, when you declare something as val, it's like being a const variable, and if it's a var, then it's not, so that you don't have a kind of a separate keyword that you prefix. It's just part of the keyword that you use for your declaration. Okay, so for integer types, doubles, chars, and kind of in some sense most of the types that you're used to, the addition of const is fairly simple. What about pointers though? Okay, so what happens if I actually do something with these pointers here? Okay, so well, first off, let's comment out that line so that this would have been happy. Okay, now when I do this, so it turns out this error was superseding the others. Even if I just go to that, I have an error. Okay, so what's going on here? It says invalid conversion from const int star to int star. What's happening is that A is a const int. And here I'm making it so that C points to A. Well, if I allow C to point to A, if this were allowed in the language, then I would be able to do star C equals 8, and that would effectively change A. So because it's safe to do here, I can't allow a pointer to a regular int to point to a constant, because then I could actually change the constant. If I want to be able to do this assignment here, I have to make it so that this is a pointer to a constant integer. And now the error that I get is happening down here because I've tried to change what it points to, and if I don't do that, this code is now happy. Can I make a constant point or a constant pointer point to a non-constant? And it turns out the answer is yes. It's perfectly happy because you're not violating any rules. If I have C as a constant, as a pointer to a constant int, and I make it point to B, well, all this says is that I can't change B through C, but that's fine. On the other hand, making the C point to a constant integer when C is not a pointer to a constant integer would allow us to violate something. The thing about pointers, though, is that there's two ways in which they can change. So the line that I put in before was similar to this. And I had a value there instead of one of my variables. But that's not the only way you can change a pointer. You can also change a pointer by changing what it points to. It turns out that when you put const here, that you're allowed to change the pointer. This is a mutable pointer to a constant integer. And so I can make C point to something else. We'll go back to where this was the A. So first it points to A, and then it points to B. I can make it point to whatever I want, but I can't change the value of whatever it's pointing to because it's pointing to a const int. What if I wanted to make it so that I can't change what it's pointing to? Well, if I don't want to be able to change what it's pointing to, I put the const over there. So now, turns out I can't do this. I can't change what C points to, but I can, and that's not going to work. Let me unconst A. But I can do this. So now C always points to A. I'm not allowed to change that because this is now a const pointer to an int. Because it points to a regular int, I can change what it points to, but because it's a const pointer, I'm not allowed to change what it actually winds up pointing to. If you want both, you can do this. And a lot of times you'll want that. Note that in some ways this is actually more powerful and more expressive than what you have in languages like Java and Scala. You don't have the ability to put on limitations like that. Okay, so we've looked at const both on primitive types and on pointers. The fact that on pointers you can put const kind of in two places, either to make it so it's a constant value or a constant pointer, or both. We'll come back in the next video. We'll talk about references and then also about const in another usage when we're dealing with classes.